All right. Wait.
Goody doody. Today it is the 4th of September already, and we are going to be talking about the structure of the persisted data, at least according to the agenda. Let's jump into it. So I think that last time we decided that we will be making two kinds of persisted data, right? The first one would be when before the actual pull with an intent to pull an image, and then once the image is pulled, we write a new something. We will decide whether it's a file or a record. Let's call it a record for today. We'll write a new record with which would be indexed by the digest of the image, possibly. And this one will basically tell us that the image was pulled successfully, and the original intent pull would be removed. Now, we know that. We know when writing and deleting happens and what we write, but we don't know uh, what is the data that we would actually, what was the information that we will be writing into these pre pull and after pull records, right?
Yeah. Maybe we could start by describing some of the attributes of
Mhm.
what we write. So I think whatever we write needs to be structured in some way so that we can evolve it in the future. Add fields or adjust how we do something. It probably needs some mechanism for versioning. So if we start with version whatever, version 1, version A, and then discover, oh no, we actually need to rework how we're doing this, the kubelet can sort of read the previously persisted stuff and recognize, oh, this was the first version, I need to interpret it this way. So structured, versioned, those are pretty generic requirements that applies to pretty much everything we write and expect to persist between releases. So I don't have a great view to other things the kubelet persists. I know it has some like checkpointing kinds of things for CPU stuff, for device stuff.
Yeah, the
I don't
CPU
actually
manager and
know.
device manager both, or the topology manager both have state files, but they're not versioned, and they have gotten bit by that in the past.
Yeah.
So we
Okay.
don't have any sort of like, we don't have any precedent for this, but also we definitely have a need for it.
Okay. Yeah, I recall those checkpoints sort of being like, oh, we didn't really think about them transitioning from one kubelet version to another version. I guess maybe just delete them when you upgrade, like, or yeah.
Exactly.
So
What to do.
let's okay. So if there's not a ton of prior art that we would want to copy in the kubelet, that's okay. I didn't know if there were really great patterns already in place that were like, oh, we should just do exactly what the kubelet's doing over here.
But what we do now could inform a future where we actually adapt the existing state files to be versioned. So that's something to think about.
Yep. We have versioning and serialized structured data mechanisms, which we use for the REST API over the wire, and which we use to persist stuff in etcd, and which we use to version and structure like configuration files that get consumed. My default is to use something along those lines for this. The mechanism is very well paved. For config files, we typically use JSON or YAML just because they're human readable. I don't have a strong opinion about what to do for these. We could output proto. I don't have a sense for how performant this needs to be. If persisting a sort of tiny JSON snippet before we do a network operation, like I think the network operation will dwarf the disk operation. Well, not even the disk operation. Like we have to do a disk operation, no matter what we put in the file. If we put JSON, like that's obviously not very efficient, but also we're not storing very much data at all. So I don't think the difference between JSON and proto in the content will really matter relative to the disk operation and relative to the network operation of the pull. And it will make humans' lives so much better if debugging an issue with this you can like actually inspect the data. So if this was like high write rate, large amounts of data, I would maybe care more about trying to do like a super efficient binary format proto something serialization. I don't know. But since I think it's small amounts of data, I would lean towards just JSON output, something like that for these records. Are there aspects that I'm missing where these would be super high frequency, or we would sort of balloon the data so that we would care more about being as efficient as possible? I guess we haven't talked about the granularity of the records. So if the intent to pull for a particular image writes a file containing just that data, that's a small amount of data. If we have a single file that lists all the intent to pull things, then maybe, you know, adding another thing and then rewriting the whole file, adding another thing and rewriting the whole file, that could become a big file, I suppose. So how granular we want the files to be is a good question.
Yeah, I could also see, I mean, not writing aside, also, I think we're going to be reading it more than we're going to end up writing it, theoretically, assuming. I mean, I guess it kind of depends on what the sort of behavior of the image is, like how many different images are being used. But, you know, for every, if we're maintaining, I guess how frequently are we checking the cache or the disk cache is also the other thing to think about. In the current implementation, we basically had it every time it was checked.
Mm-hmm.
But we could be a little bit smarter about it if we know that the kubelet hasn't crashed.
Yeah. Do you know what the kubelet does in terms of, like it has the garbage collection image loop where every once in a while it goes and checks all the images. Does it remember those in memory, or does it?
Yeah, it keeps those in memory.
Okay.
Yeah, it's like continuously asking the CRI what images do I have. It does that every like 30 seconds or something, and then it keeps its own like internal cache of that.
Okay.
And then like on some frequency goes through all of the running containers and checks, is this container, like, do I need this image anymore?
Okay.
And it's always keeping track.
Okay. If it's keeping a list, obviously just the list of image names and maybe associated tags is probably not that big. If it would be reasonable to also keep the information about whether those were pulled, like how they were pulled and which hashes or credential coordinates were valid for them. I'm trying to think if that's sort of roughly a similar amount of in-memory data. Like the fastest thing would be on startup, read in the, you know, pull information, credential information for images and hold that in memory, and then work from memory and just persist changes back out to disk. Then you're not having to sort of read a file and decode it on every image check, which would be ideal. If the bookkeeping the kubelet has to have in memory to do that is small-ish, that might be reasonable. I think we had said it would definitely be smaller than the image content, which is why we're okay persisting it to disk. But I could see it being bigger than the image name that the kubelet is currently keeping in memory. So I'm not sure we can keep it all in memory all the time. Okay, so that's an open question. Will the kubelet keep all the bookkeeping in memory and then just persist changes back out to disk, or will checking a particular image involve reading in the bookkeeping for that image? And there, I guess there's a middle ground where you say it'll keep 1,000 entries and it's a LRU cache, and like I think it's reasonable for the kubelet to assume it's the only one manipulating the bookkeeping. So I'm not worried about like something else coming in parallel and messing with files and like trying to make the kubelet reread files that someone else changed. I think that's out of scope. But okay, so we can handle this with an interface and have an implementation that doesn't cache at all, one that reads from disk all the time, and one that uses a cache. Like we can put it behind an interface and then decide what to do later there, I guess.
Let me ask some real quick questions, Jordan.
Yeah.
One, we had mentioned encoding, and I assume we haven't gotten far enough in like the CBOR land to consider that as a valid choice yet. That's just mostly me just asking a question because I don't actually remember how far we got with CBOR.
It's alpha, like it's pre-alpha, like it's alpha and not even fully wired yet.
Okay, I'll just ignore that. It was just I just wanted to mention it because it is technically a choice of some sort. The other question I had was just thinking about some of the conversation from last time and sort of the before pull state and the after pull state and all those things. Is like the transactionality you get from something like Bbolt like a better approach than like having tiny little files that you write in a very specific order? Because aren't you just basically emulating like the write-ahead log of a file-based database?
I think there's more to it than that, because you're interleaving like these data records with some other non-database operation, which is the image pull. So like even if you were using Bbolt, I think you would still like record an intent to pull thing. Or are you talking about like if the kubelet crashes?
Sure, yeah, like in those states, right?
Because it's not just a database transaction, it's data entries and some other real world pull operation. Like I don't think something like Bbolt really helps you, because you still have to do a before database thing, go do the real world pull, and then do the after pull database operation.
Okay. So we don't think transactionality there helps because of just the nature of external calls. Is it desirable to not have to manipulate a bunch of individual files and just have like a local database that just does the database things and you just have keys and values in the database?
I think if we do the bbolt thing, we have to keep it all in memory.
Don't remember.
Because it, so bbolt, I don't think it would work to have like a bunch of little like per image bbolt file log things. So because there's overhead there, there's like a minimum write ahead log size that it reserves, and like that would be actually really big. So I think if you did something like bbolt or SQLite or like some databasey approach, you would have all of the records for all of the images in a single database file log, whatever.
Mm-hmm.
I actually don't know enough about bbolt to say this with 100% certainty, but I thought that it typically operates on like keeping a decent chunk of it in memory, if not all of it in memory.
I don't recall that, but I mean, I can spend some time poking at it just because I'm kind of curious now.
Okay.
But let's presume for a second though, like that's not the case, and it's reasonably memory efficient. Like I think what I'm more curious about, like, what is our rationale for like, I don't know, making like per, was it image tag files? I forget what the specific granularity is, but yeah, it just,
I think simplicity, like flat files on disk are very easy to reason about,
mhm.
and we don't have the like, well, yeah, I think simplicity. Like the files are here, they're inspectable. When you garbage collect an image, you delete the corresponding file, I guess, that has its bookkeeping info in it. On startup, any files in the intent to pull folder need to be gone through and like dispositioned one way or another. Like I don't know. The other bookkeeping things that kubelet does, which are not exactly the same, but it does set up file structures for like volume mounts and pod logs and things like that. Like most of the things that kubelet does are just sort of persisted directories and files that are named to match like container UIDs and pod names and things like that. A single, not exactly opaque, but like a single blob that is like, and here's the credential bookkeeping information, which basically you need a Go program, which is the sub package in the kubelet that is written to understand this thing. Seems harder to reason about. Seems harder to write anything else to like fix up or clean up, or you kind of just have to delete the whole thing or pull code out of kubelet to understand it and mess with it. I don't know.
So Jordan, I don't know if you remember from the last discussion, we did, interestingly enough, we do use bbolt for our metadata and containerd for all the image information and state for the containers. Also, additionally, we talked about we could store a bit Boolean or whatnot regarding a particular image, whether it was pulled through cry or not, right? And then when you ask for the state of the images, we would provide you that that this image was pulled by cry, so you would have that your a priori state stored actually in the runtime.
Yeah, pulled by cry though, like we still don't know, did an admin run cry control pull, or did the kubelet ask cry to pull it, like it's useful to know that, but I'm not sure it's sufficient. Like I think the kubelet still has bookkeeping to do to know what it should require of individual pods.
And we also talked about the second Boolean would be whether or not a credential was used on the poll. And we could even calculate the same hash if the sufficient information would, or if you passed us the hash that you want us to keep, basically an ID that
Yeah.
we could give back to you. And that would be, then you don't need a Boolean. We would just give you the ID that was used, that you passed us. I'm just trying to help out here. At least on the pre-state information, it seemed that that was a good opportunity, and it is transactional.
Yeah. I like the idea of being able to pass in an ID. Actually, I give a mouse a cookie and he asks for another. Multiple IDs, because we have the coordinates of the credential and we have the hash of the contents of the credential, and we're saying that a pod with access to either of those would be allowed to, you know, we wouldn't need to re-verify. So we have at least a couple ways to indicate the credentials, but I like the idea of being able to tell like.
Yeah, and just for poofing it up, we could use the annotations that we pass for the image pool. For now,
Okay.
or we could just modify the API a little bit, add some extra fields.
Interesting. Okay. Getting back to your question, Mo, I'm not like mostly I don't know enough about it to know, and so my curmudgeonly default when I don't know enough about something is to say I don't know, I don't understand it, so I couldn't endorse it. if again, like if there are people working in the kubelet who know all about this and like understand how to operate it cold and it's actually reasonable and pretty straightforward and simple, I wouldn't object, I guess. But yeah.
I mean, I'm a fan of keeping it simple. My desire from the question is mostly I don't want to reinvent a bunch of Beeble specific or file-based database type specific things using just like tiny files all over the file system. If that's what we need, if we feel that that's not really what we need, and we just need like simple plain text files with just tiny bits of metadata and most of the state tracking is sort of inherent to the fact that we're trying to couple two systems that don't really know about each other, the kubelet and the CRI and their state. And we feel like the files are just going to be as sufficient and good enough. I think that's fine. Like, I mean, we use basically JSON YAML files for everything in Cube, right? Like that's kind of user facing. So if we think that's sufficient here, I don't feel the need to push on that. I mostly just wanted to ask to make sure that we didn't forget like the obvious thing that, for example, like a mobile app developer would do, right? They would always use like SQLite or something like these. They wouldn't start writing plain text files to disk, right? Because it's just not sort of their mode of operation.
Yeah. Yeah,
I think that if we can this is fine. I think that for beta for alpha, it's like let's at least do something. And I think that files seem simple enough, and then we could even get back to this question eventually, like when we're doing alpha B2 or beta. I'm not sure if we could hide all of this behind an interface too.
I like the idea of modeling the steps we need as an interface, and then kind of doing a first pass with a simple, maybe simple file approach. Maybe do it with a serialized JSON, little API type, and then see how it works. And if it's too slow, maybe we serialize with proto. And if managing the files we find out is like messy and nasty, maybe we pivot to implementing the interface with a bbolt or something like that. But modeling how the kubelet interacts with this thing as an interface so that we can change, but starting with like the simple, inspectable, easiest thing that could possibly work, that's where I would lean. Yeah.
Yeah, I think I agree with that. I think that makes sense. And the one question I have, and this is sort of generic for both, or really any approach in this, is it's unclear to me exactly what our expectation is around versioning. Like, would it be kind of like what we do with etcd, where we remember every version since the beginning of time, no matter what, even if we only write at like the newer versions, because we don't have a mechanism for.
So we do have a mechanism. Like when the kubelet starts, we're already saying when the kubelet starts, we're going to have to initialize this thing. And part of initializing is going to see, like, do we have stuff left over from when we previously crashed? Are there intent to pull things we need to deal with? And like, so there's already sort of an initialized step, right? That is where we can do like version migration. So if we start and we're like alpha, I mean, yeah, if we write alpha JSON files and then we realize, oh no, actually we needed to structure it differently. I mean, it's still alpha, so we could just say like, whatever, delete it, it's alpha. But when we get to a point where we actually do care about, keeping previous version stuff upgradable and migratable, I think that moment is where we can do that migration, right? So we have beta 1, beta 2, like after there's been a version bump, the kubelet can, as part of its initial startup, say, all right, I'm going to go look for things in beta 1 format, and as part of my initialization, update them to beta 2. So we don't, like, there's an opportunity to do a migration if we want to, if it would be useful to clean up the old stuff, if we want. We don't have to, right? If it's easier to just say, we can read beta 1 or beta 2, whatever, then we could do that as well. But if the kubelet's the only reader writer that we care about, and we have a point where we could hook in a migration, which we do, then I don't think we have to retain everything forever.
Yeah. And when this is all happening on kubelet start, I think what you're saying is we can safely rely on nothing else needs that data at that moment other than the kubelet itself. And so it basically has full authority to write it, change it, whatever, get it into whatever state makes it happy, and then you can actually continue with its regular flow.
Yeah.
Okay. Which I think is a much smaller problem than the general etcd problem we have with API server, where there's many writers to the same data, skewed
On
versions.
other machines, on unknown versions, and yeah. So we are asserting ownership of this, and we're saying the kubelet is the only reader writer we are considering, and it's going through this interface. So any locking that needs to happen or anything that needs to happen on startup before the other, methods of the interface are available, like the interface is how the kubelet interacts with it, and we're saying the kubelet is the only owner of this directory and this data. Okay. My mental model was one file per image that was being pulled. So if I know the kubelet can pull in parallel now. So if the kubelet's pulling 3 images that are different images in parallel, then there would be 3 intent to pull entries or files. Sorry, that was my initial thought. Obviously, image specs have characters that are not file safe characters, so they have slashes and colons and things. So you need a way to take a given image spec and translate it into a file. So you could do a hash of it, or you could do an escaping of it, or I don't know. There's different.
I like hashes because if we escape it, then we have to figure out Windows escaping versus Linux escaping. It would really
I like hashes as well. Do we have to worry about collisions on hashes?
just use SHA-256, and then there can't be any realistic collisions.
Is the big sky approach. If you get a collision, if you happen to be pulling two images in parallel that collide on a hash of their image spec, you like win a prize. Contact us for your reward.
Yes.
Okay.
I mean, isn't the chances of a SHA-256 collision like you have a higher chance of like running into a black hole while sitting on Earth?
I don't know. All right, I think hash of the image spec is as good a starting point as any. We should put the actual image being pulled into the file so that we can double check, like when we're going to look up the thing. Image hash gets us to file, read the file, make sure that the thing inside actually matched what we thought it was. And then the other things we said we would record, like whether it was being pulled anonymously or with node credentials or with pod credentials, and if pod, then the dimension or the location in the hash. For digest entries, we already have a hash, right? Which is the digest. Does that match people's expectations? So the image is like SHA-256 colon whatever. I would think it would make sense to just use that as the file name for that entry.
Yeah, fair enough. Just a heads up, it's not necessarily always going to be SHA-256, the image reference.
Yes. But this, so including that in the file name would not bother me. We might need to replace the colon with something to make Windows happy. But SHA-256 underscore whatever, like taking the digest, making it file safe, because it's already an algorithm colon.
Right.
Right. So that seems plausible to make file safe.
Agreed.
Okay. Do we need to? So for intent to pull, we expect that to be limited to the number of parallel pulls the kubelet would be doing. So if I think by default it does 1, and you can optionally let it do more in parallel. But still, like we're expecting small numbers, like 5, 10, 20, maybe 100 if you're insane. Like small numbers where a single directory with all of the active intent to pull files live. Like I don't think we're going to balloon a directory to problematic sizes. For digest entries, that we expect that to be limited to the number of images on the node, present on the node, which could be lots and lots and lots, right? Do we need to partition that directory to avoid all the files being in the same directory? I don't know enough about like directory file count limits to know.
I don't think it will make that much of a difference because we'd have it be the subdirectory. I mean, it's going to be like there's going to potentially be like inode limits on the disk, and that's like we're not going to avoid that by having additional layers.
Okay. Okay, so if we're looking up specific files, we're going directly to the file name. Like the pod's going to run an image, the image exists, we get the digest, we derive the bookkeeping file from the digest name, and we look up that exact file if we don't have it in memory already. So that's direct access of a single file. Listing all the files in that folder. Again, I don't know like the practical limits of directory file counts, and if it makes sense to have to split it by like prefix or suffix of the last 2 characters of the hash or something. I just don't know. If we want to start with it flat and see if we run into trouble and iterate, I could buy that.
Well, we can put it this way also. Every SHA, every like unique ID that exists will also exist on disk, under the overlay directory of whatever the runtime is. So it's already gonna exist in a flat structure. In fact, like in Cryo, we have every layer. There's a directory with every layer of every image, which is going to be more. There's always more layers than there are images.
Are those peer directories, or are they like sharded under like?
No, they're all peers.
They're all peers. Okay, so if every image, if every digest already exists on disk, peer to each other in a file structure, then I think like if there's a problem with that, we already have a problem with that. So matching that here is
right,
fine.
exactly. And any limit that we're going to hit is going to already be hit by the images. Even like disk space is the same way. Like we're never going to get close to
I'm not worried about disk space because these are going to be tiny relative to the actual content of the images. I mostly wanted to make sure we weren't going to hit some bizarre limit with file system. Like you may not have more than 10,000 peer items in a single directory. Okay. Cool. Yeah, I'm happy with this as a starting point. I'm really happy if the way the kubelet interacts with it is with an interface, so we can adjust the implementation without touching any of the kubelet logic that we talked about last week, and like tweak things like shift from JSON to proto, or shift from loose like individual files to like a bbolt thing, or yeah, I'm happy to encapsulate that so we can adjust it if needed.
So now that you're storing it all on disk, did you want to continue to have the in memory, or is that not necessary now, I guess? I think we're already going to be rewrite locked to the disk for all these records that we're storing.
Yeah, I mean, we already had to do disk because we have to survive restart.
Right.
I would be fine with starting without a memory layer, and like when you ask it about a particular image, it goes, hits the file, loads it, and gives you an answer. It's easy to build a LRU cache or a memory layer on top of that if we want to. And we can see how it does performance-wise. What do you think, Mo?
Yeah, it would only be advantageous if we were still doing the policy around timeouts. Expiry. Without the expiration, it doesn't make sense.
When the kubelet checks if an image already exists, it's doing that via a gRPC call to the runtime, right?
Yes.
And is that like going out and hitting disk, or is that hitting like?
It has we have an in memory.
Okay.
On the status, so it depends. When you do the pull,
yeah,
then it's going to hit disk. Obviously.
I don't have enough intuition about how frequently the kubelet is doing this and how long the gRPC calls to the runtime take relative to like
Right.
pinging a bookkeeping file. Like if it's not happening in a hot loop, basically,
Right.
and like the time is like relatively comparable or shorter to just pull in a tiny file and read it, then I would probably start with that. Are there other like IO, IOPS things where like poking the disk a bunch is gonna hurt us? It seems like there shouldn't be. I don't know.
If
It
you're under
could.
extreme pressure and the disk is locked out and you're currently trying to bring a pod down while you're bringing another one up, this can be locked. You can get some timeouts.
Yeah.
I think another risk is like using up qubit CPU time waiting for the disk. Like, kernel, if the kernel is throttling IO generally and the qubit's waiting on trying to get stuff from disk, then that could use up a bunch of CPU.
Yeah.
One related question I have to all of this is how realistic are we to get errors that are not like, oh, the file doesn't exist, therefore, go to the default path. Like and my thought process there is what is the expected behavior of the kubelet? Does it try to limp forward in some way, or does that image pool just fail? Or
That's a good question. So if the kubelet holds the bookkeeping in memory, then it can always answer a question about whether a given pod needs to be re-verified. Like you'll never hit an error case deciding if a pod needs to be re-verified. You might hit error cases trying to persist the results. Like if it tries to pull and you can't persist intent to pull, then I think that's an error. But then you fail to pull. Or if the pull completes and you can't promote to the digest entry, maybe that's an error. So, but the errors are on the like right path. If the kubelet doesn't hold bookkeeping in memory, then you can get errors on the read path. I guess I don't know what I would do. I guess I would fail safe, meaning an entry exists for this image. I couldn't read it. Therefore, I'm going to say you have to re-verify. Like this is an image I pulled. A file exists for this image, but I can't decipher it. Like I got a disk error or a decoding error or so I guess you have to re-verify.
That's a good fail safe.
okay.
We have the same, so I guess we have the same issue on startups, right? So you start the kubelet and it goes and looks at this list of files and it either decodes them at startup time and populates its in-memory cache. And if one of those files can't be read or decoded, then I think the next time the kubelet's asked about that digest, it should also say like, I don't know, it was an error. Like I know this is an image I care about, a digest I care about, but I don't know what answer to give you. So yeah, re-verify.
And
So
clean
we have
up.
the error state, whether it happens at startup time when we're populating our in-memory stuff, or whether it happens, per check if we're going direct to disk and fail for some reason.
Yeah, any error should just re-verify the image.
Yeah.
And it could even be an unknown version, right?
Yeah, I mean, yeah, the kubelet forgot about the version. We deleted the alpha version, and this is the old alpha serialization data, or it got corrupted somehow, or like, and then when you go do the re-verification, the result of that re-verification should persist back to that file and like put you back into a known state, at least with the results of the most recent verification.
Yep, and overwrite. Either overwrite or clean the file, either way. If there's
So it's like a self-healing, yeah. If there's
yeah, I like it.
If we hit issues, we fail safe by re-verifying, and the result of the re-verification corrects the file.
Okay.
I like that better than the failure mode of the topology and CPU checkpoints, where it's like, sorry, your kubelet's dead. Just go delete stuff manually as an admin.
So wait, remind me though, the way you just described it sounded like kubelet would have to always keep all of this in memory.
It doesn't have to. I was saying if it does keep it in memory, then we don't hit spurious errors where like a temporary disk blip or timeout means we can't answer a question.
Mhm.
So I don't know. There are certainly benefits to keeping it in memory. If it's a tiny amount of data, like if we're not going to eat a lot of memory by doing that, then we might want to just keep it in memory. But you always have the possibility of there being files that couldn't be read for some reason, whether it happens at kubelet startup time when we're filling an in-memory representation, or whether it happens, at check time if we don't have an in-memory representation and we're going directly to disk. You always have the possibility of files that can't be decoded or read for some reason. Once
So
we
would
have,
you still, sorry, would you still like the first version to be just files, or would you like to start with an in-memory version right away?
just files is probably the simplest possible thing that could work. I think it also keeps you honest. Sometimes in-memory stuff sort of takes shortcuts that when you actually have to serialize to file and then next read actually has to read from file, like it keeps you honest about like all the relevant stuff is actually in the data that's getting serialized. Building like an LRU layer on top of that is pretty easy to do. So I would probably start going to disk, reading from disk, and then build on top of that.
Yeah, that makes sense. I'm just checking, for whoever is going to implement this would like to know.
Yeah, the code you're starting from already has in memory, so you're going to have to remove it. Yeah. But you can do it with the last commit if you want, and just re-verify.
Yeah. Okay. So I think the next steps are the interface, like coming up with the actual interface that the kubelet will use, and sort of specking out the like the actual little, for lack of a better word, API type. I mean, it's a tiny type for the intent to pull entry and for the digest entry. We had already done a sketch of the config options on the kubelet side. So I think in terms of surface area, that's the surface area. The interface the kubelet uses, intent to pull data, digest data, and kubelet config data. And then we can, I think that combined with the sort of behavior we talked about last time, which Mo asked for a mermaid diagram, and I wholeheartedly thumbs up. I love mermaid diagrams.
Santa made some ones. They even have colors. I was very impressed.
Oh yeah.
I think that's enough to fill out the KEP. Like that is the relevant behavior and surface area and like specifics of what's going to get persisted. I think that's enough to fill out the KEP, and then we can transition to implementation.
Good. Nice. Jordan, I think you've been reviewing Standa's PR, right? Or
very intermittently, and I apologize for that. Uh, um, I am happy to continue doing that, booking like an hour or two. I mean, we could use the same time next week. It's helpful to just like book a time for
Yeah.
a high bandwidth iteration on the KEP PR.
Yeah, so I'm happy to be here, the same slot as as every week until we're comfortable. Like if you want to take the action item of reviewing Standa's changes to the KEP so far, and then like asynchronously, and then having synchronous meetings to discuss it together to make sure we are aligned. I think that's fine.
Yeah, I'm happy to attempt that. Reality usually means that the sync is the forcing function to actually do the review.
I mean, but that's also fine. Like I'm okay if next week we sit here quietly and review the KEP, and then the following week we actually talk about what we read. If that's what it takes, I'm totally fine with that.
Okay. Yeah. Any other areas that we haven't talked through that I think this is kind of end to end what we needed.
Yeah, I think it was after you map in what we talked about, never pull, that kind of stuff.
Okay.
Yeah, I think this works really well. Storing the a priori data, that'll work really well. As far as knowing whether or not it was pulled by kubelet, as far as kubelet's concerned.
Exactly.
Right. And then we could always, follow up. We could do a, if an admin manually pulls it with auth from kubectl or something, then we could also store that as well. Down the road.
Well,
For the
like a
never pull.
future
For the
thing,
never
it
pull.
doesn't exist today, right? Like there isn't a kubectl command today to tell the kubelet.
Not kube control, like crowd control pull.
No, I think Mike was saying theoretically in the future you could have some Kubernetes specific way of pre-populating images.
Pre-populate, right.
I see.
And that should be recorded, right? With the intent like, hey, the admin told the system to pre-pull it. So like we know that because we were in the entire loop, so we should record that
Yeah.
somewhere.
Gotcha.
Yeah, I like this. It closes out the original KEP's to-dos. One was to, figure out how to do storage, and the other was to do the never pull. Close that scenario down as well. I think you've done both, Jordan. So
Great.
I'm on PTO next week. But
Okay.
when I get back, I'll give it a good review.
Sounds good.
All right.
All right, we'll look for the updates and review them async, and then sweep up whatever we haven't reviewed next time. Thank you.
Awesome. Thank you. Thank you all.
Thanks. Bye-bye.
Bye.